All right, today we're tackling a really big idea. What if we could build an operating system for cognition itself? We're going to dive into this concept called CognOS. But before we get into what it is, we've got to understand the problem it's trying to solve. So, for anyone out there who's actually building with AI, that column on the left probably looks painfully familiar, right? This is what we call the DIY plumbing problem. We're talking custom scrapers, brittle RAG pipelines, hard-coded queries. It's this fragile, tangled mess that's a nightmare to manage. Now, the column on the right, that's the dream. Clean, declarative abstractions. CognOS is all about bridging that gap. It's about getting us out of the business of being AI plumbers and letting us become AI architects.
Okay, so before we jump into the solution, let's just step back and define what we're even aiming for. What is a cognitive system, really? And this definition is so important because, look, it's not just about running a model. It's about building an entire engineered architecture that can perceive, reason, act, remember, and here's the absolute kicker, adapt. It has to move beyond just executing a fixed set of instructions.
At the core of any thinking system, whether it's you and me or a machine, there's this fundamental loop. It's a cycle, right? You perceive something from the world, you reason about it using what you already know, you take an action, and then, and this is the part we always forget, you reflect on it to learn and get better next time. The thing is, most AI systems today, they can kind of do the first three steps, but that last one, reflection, that's the missing piece. That's where they almost always fall flat. And this quote from the legendary Marvin Minsky, one of the founders of the MIT AI Lab, just hits the nail on the head. This isn't just about building clever software. The whole point, the decades-long dream of AI, has been to build systems that can do what minds can do. The challenge has always been getting from these little, isolated, single-task programs to a truly integrated system that can perceive, reason, and learn all in one go.
And look, this search for a solution is not new at all. We are absolutely standing on the shoulders of giants here. I mean, you can trace this all the way back to Blackboard systems in the 70s, then cognitive architectures in the 80s, you had IBM Watson in the 2010s, and of course, today's modern agent frameworks. Every single one of these was a step forward, but they all struggled with things like governance, or scale, or just being truly ready for production. And that is where CognOS comes into the picture. The whole goal is to finally make that cognitive loop real in a way that's actually production ready. And it's all built on three fundamental pillars.
So here are the big three. You've got the event fabric, which handles perception, the knowledge mesh, which is all about memory and reasoning, and agentic orchestration, which takes care of action. See how they map right onto that cognitive loop we just talked about? But here's the key difference. They have governance baked right in from the start. So let's break down each one. Okay, pillar one, the event fabric. Think of this as the system's central nervous system. The best way to get it is to think about system one thinking. That fast, automatic, gut reaction stuff. It can ingest a flood of signals and react in milliseconds. But, and this is absolutely crucial, unlike some brittle script that just fires off, these reflexes are governed. It has built-in storm brakes and budgets, so a single noisy signal doesn't cause a total meltdown. It's all about having speed, but with safety. All right, next up, for the system to reason about anything, it needs a memory. That's the job of the knowledge mesh. Now, what's really cool about this is that it's multi-representational. This isn't just one kind of database, like a vector store. No, it supports graph, vector, relational, cubes, blobs, you name it, and they're all interlinked. This lets the system transform all that raw, messy data into governed claims with crystal-clear provenance, so you always know where a piece of information came from.
And that brings us to our third pillar, agentic orchestration. So if the event fabric was fast, system one thinking, this is its counterpart, the slow, deliberate system two thinking. This is where the system carefully plans and takes action. It coordinates complex tasks across AI agents, deterministic tools, and even human agents. And again, crucially, every single action is governed by policies, by budgets, and has clear human-in-the-loop checkpoints. This is how you prevent mistakes or, runaway costs. So, you might be wondering, what's the secret sauce that holds all of this together? Well, it comes down to one simple but incredibly powerful principle. Everything is a URI addressable resource. Now, for all the architects and engineers watching right now, you know this is a huge deal. It means no more hard-coded endpoints. It means you can compose, trace, and govern every single component in the system with an insane amount of flexibility. Okay, remember that fourth step of the cognitive loop we talked about? Reflection. In almost every system out there, this is an afterthought, if it's there at all.
But in CognOS, reflection is a first-class core capability. The system is literally designed to watch itself. It's analyzing its own performance metrics, it's repairing contradictions in its own knowledge base, it's even evaluating how effective its own agents are. This is how a system actually learns and adapts, instead of just blindly executing tasks.
So when you put all of these pillars together, what you get is a fundamental shift. It's a massive leap forward in the level of abstraction we can work at. It's what we call the declarative leap.
And probably the best way to really wrap your head around this leap is with an analogy that I'm sure many of you know very, very well: Kubernetes. Think about it. Kubernetes totally changed the game for compute, right? We went from managing individual servers to containers, and then finally to just declaring the state we wanted in a K8s manifest. Well, CognOS does the exact same thing, but for cognition. We're moving away from brittle, imperative scripts and towards declaring high-level cognitive resources. Simply put, we stop being plumbers and we start being architects of intelligence.
And what does that mean in practice? The impact on productivity is just massive. We're talking about complex workflows that used to take months of custom, bespoke engineering, now being declared in a matter of hours. You get to focus on the what, and you let the OS handle the how.
So what does this mean for us, the people actually building these things? Does it make our jobs obsolete? No way. It elevates our roles. Your developers become designers, thinking in YAML or JSON instead of low-level code. Your operators are looking at high-level dashboards, not scrolling through endless raw logs. And your human experts? They become reviewers, stepping in only at those designated high-leverage checkpoints. It's just a much smarter, more strategic way to work. So we'll leave you with this question. For decades, our imagination has been shackled by the sheer complexity of the plumbing. But what happens when that's solved? When you have a governed, scalable, and self-improving foundation for intelligence just available? It opens up a whole new world. If the how is finally taken care of, the only question left for us to answer is, what cognitive systems will you build?